Differential equations, we're in our last review of the semester, the 4.4, 4.7 review, really getting us ready for our last summative, which will be on Thursday, May 7th. But let's take a look at solving the differential equation by undetermined coefficients. And this is really going back to section 4.4. So first of all, we are going to do some work, and we assume y equals e to the mx is a solution. Now, when you do that, you're going to get m squared minus 3m minus 4 is equal to 0. We always start by solving the homogeneous differential equation, setting that equal to 0. So we'll get m minus 4, m plus 1. And it's not going to take us too long to see m equals 4 and m equals negative 1. So it's at this point where we can set up, from these solutions, we can find what we call the complementary solution. And forgive me, I need to put in a constant, c1 e to the 4x plus c2 e to the negative 1x, or just negative x. And, that's wonderful, that's great. It's just that now we have to do quite a bit of work to deal with that particular solution. And whether it's looking at that table, and there was the PDF on Google Classroom, with that, it's also in our book. When you have 3x times e to the 2x, 3x is really a linear function. Some constant of x plus a constant, ax plus b, that's the most general form. And then we'll have e to the 2x right there. So really, that's the starting point. That's where we want to really make sure we're comfortable with that. So from here, if we took a derivative, well, my goodness, this sure looks like we're going to need the product rule. Indeed, we will. Here's your u, here's your v. Let's just say that we took our function u and we multiplied to that v prime. Well, the derivative of e to the 2x, a 2 is just going to come out in front. But how about we just multiply that 2 inside there? We could leave the 2 out in front of the parentheses, or we could just bring it inside. Honestly, it goes either way, doesn't it? And then we could have u prime times v. Well, the derivative of ax plus b, well, I hope we'd all agree, would just be an a times e to the 2x. And, of course, we could do some cleaning up, and that would be, all well and good. We could definitely do that, and we will in just a moment. However, I also want us to realize we're going to need a second derivative. And with that second derivative, I guess what I just want to point out to you at first is, again, we're going to focus in right here, and we're going to say, hey, we've got another product rule. We've got another product rule just for what I've highlighted in yellow. So imagine that we've got our 2ax plus 2b. Well, once again, we could say, well, wait a minute, we'll have e to the 2x, but when we take the derivative of that, a 2 comes out, so we'd get a 4ax plus 4b, right? And then we could say plus, well, then we'd need to take the derivative of that 2ax plus 2b. That would just be a 2a, wouldn't it? So we'd have 2a multiplied to e to the 2x. So really, that is coming from the product rule in yellow. And then we're going to have to go ahead and take a derivative of what we had up on top, the a e to the 2x. That's just going to be a 2a e to the 2x. So at this point, I just want to do a little bit of cleaning up before we start substituting. Because that can really be helpful in terms of, just helping us get to our final answer. let's come back here to the first derivative. You know, as you were going to distribute, you would get a 2ax e to the 2x. And then right here, you'd have a 2b e to the 2x. You also have this a e to the 2x. So I guess what I'm really going to suggest is, how about we just factor that e to the 2x out from both of them? Okay? So really, that's what we've got for our first derivative. And of course, you could have thrown in that little additional step showing a 2b e to the 2x plus a e to the 2x and then factor it out. But I hope we're at a point where we more or less just see that. Let's take a look at our second derivative here. And again, if I were to distribute, we'd have a 4ax e to the 2x. And then what? Well, we'd have this 4b e to the 2x, and these are like terms. That actually becomes a 4a e to the 2x. But these are like terms also, so tell you what, just going to factor out that e to the 2x, leaving us with a 4a plus 4b e to the 2x. Look at that. So we are going to need y prime, and y double prime when we get to working out the values of a and b. And let me actually space this out a little bit more. Here's the original differential equation, right? And what I'm going to do right now is say, well, I need y double prime. Well, that's right here. I'm going to say that's 4ax e to the 2x plus a 4a plus 4b e to the 2x. Then we go to right here, this y prime. And see, we're going to plug that in right there. But you can see it's asking us to distribute a negative 3a in front of that. So I'll have a minus 6ax e to the 2x. And tell you what, I'm going to put the negative 3 inside those parentheses. So that a plus 2b, I just multiplied both of them by the negative 3. Then what? Well, we're going to come back up here to our y, and we're going to have to multiply by a negative 4. So once again, I'm just going to multiply that negative 4 inside there. So we're getting there. We're getting there. Tell you what, I hope you can see a couple of things here. First of all, there are really two different types of terms. Truly, they're on this left-hand side. Just want to really make this jump out. They're terms with an x e to the 2x. And that's right over here, too. See if we distribute that. They're terms with an x e to the 2x. And let's combine those like terms. I hope you can see right here, this is kind of like a streamlining some work. You're going to have a positive 4ax e to the 2x. Right over here by this check mark, you've got a negative 4ax, and then you distribute that e to the 2x in there. Those two terms are going to cancel each other out. So what are we going to be left with? A negative 6ax e to the 2x. Then we're going to have terms with just an e to the 2x. And that's really what we're seeing here in yellow. And of course, this negative 4b has a e to the 2x right next to it also right? So let's go ahead and see if we could, real quickly, put this all together. Hopefully we can. As you're wrestling with this, as you're trying to work this out, I hope you're going to see that this 4a right here, e to the 2x, and the minus 3a are just going to cancel out to a 1a. So I'm just going to leave that as just an a. Let's take a look right here at the 4b e to the 2x and a minus 4b e to the 2x. I hope you're going to see that's going to completely wipe out, isn't it? And what's left in yellow? Just that minus 6b. So whether you distribute and make this turn out for a 1-by-1 match, or if you're just highlighting and realizing you can combine like terms this way, you're going to get the same answer, of course. Hopefully this is making some sense for you. On the right hand side, let's see, we have 3x e to the 2x. We also have just a 0 e to the 2x on the right hand side as well. And why are we being so emphatic about this? Well, what's in front of an x e to the 2x on the left side? Well, a negative 6a. And what about on the right? Well, we've got a 3. So a is going to equal, divide by negative 6, 3 over negative 6, you'll get negative 1/2. Then right here, your a minus 6b, well, that's going to have to equal 0, right? That's what you're matching up with over here. So you're going to have a negative 1/2. How about we add a 6b over here? It might just make life a little bit easier. Multiply by 1/6, and you'll get negative 1/12. So we saw up above that our particular solution was ax plus b. Well, what was our a? Our a is going to be negative 1/2, right? That's our ax plus b. And what about our b? Well, our b is going to be a negative 1/12. And we'll have e to the 2x, right? So we're going to have to take these two things and blend them together. So it's a little hard for us to see this. Your general solution is going to be your complementary solution, which was c1 e to the 4x plus c2 e to the negative 1x. But then you're going to add to your particular. Your particular solution, that's what we had right up here. That's what we have finishing this up. So we're going to have a negative 1/2 x minus 1/12 e to the 2x. Because that's what that particular solution was really all about. We found our a, we found our b, and here was our complementary, here's our particular. So hopefully that's going well for you. We've got one last problem. We'll be picking that up very soon.